Welcome to class of physics. In previous video we studied about scalars, vectors and vector products like dot product or scalar product and cross product or vector product. In this present session we are going to study about the next concept, gradient and their physical significance. Before that, let's see the operator which produces gradient, divergence and curl. So here that operator we call it as Dell operator. So this symbol indicates Dell. So what it is? It is a differential operator. By itself it has no specific meaning, but it becomes meaningful when operate on a scalar or a vector quantity. The Dell operator is given by del equal to x cap dou by dou x plus y cap dou by dou y plus z cap dou by dou z. Here this x cap, y cap, z cap are the unit vectors along x, y, z axis. Actually we have to write this as dou by dou x into x cap. So just to avoid the confusion whether we have to multiply or differentiate this x cap with respect to this s, for that I am writing this unit vector at the left side of that differential term. So this is the Dell operator. Using this Dell operator we are going to produce divergence, curl and one more is gradient. So how to operate this Dell operator with scalar and vectors? In which way we have to operate? So first consider a normal vector. An ordinary vector a bar can multiply in three ways. This ordinary vector can multiply in three ways. So that is multiply by a scalar a. When you multiply a vector by a scalar quantity a, then that will becomes a into a. Okay, so this a indicates the multiple of scalar quantity with the vector quantity a bar. And another way is multiply by another vector b bar. We can multiply a vector by another vector y dot product. So that is a dot b, vector a dot vector b. And one more is multiply by another vector b bar with also y cross product. Here again we can multiply two vectors y cross product, then it is a cross b. So like that there are three ways the operator del can act. One is act on a scalar function f, del f, call this as del f, so that we call it as gradient. This can be read it as gradient of f or del f. We can call this as del f or gradient of f. F is a function, scalar function. That del f we call it as gradient. And another way of operating this del with vector quantity. Okay. Act on a vector y dot product, that is del dot phi. Here del is the operator, this is a dot product or a, and this is a vector function phi, or we call it as vector field. So this we call it as, this operation we call it as divergence, or we can call this del dot p as divergence of phi. And one more is act on a vector phi y cross product, that is del cross phi. This del cross phi we call it as curl. Again we can call this del cross phi as curl of phi, that is curl of vector field phi. So like that this del operator can act on three ways on our functions. It may be a scalar or it may be a vector. Now we have to study one by one. The first thing is this one, act on a scalar f, scalar function f, that we call it as gradient. What is gradient? From the definition of del, we can construct the gradient. This gradient, divergence and curl, all these three are constructed by the del operator only, on which it is operating. That is the important, that will give the resultant. The del operator del is given by del equal to x cap dou by dou x plus y cap dou by dou y plus z cap dou by dou z. This is the important term, please keep in mind. Next, on which function it has to be operate? The function is here, t equal to t of x, y, z. Then the gradient of t, that is given by del t, is equal to, we have to multiply this t of x, not a multiply, we have to operate on this function, don't call it as multiply, operate on this function t. When you operate on this function t, that means to this functions we have to operate t of x, y, z. So then this dou by dou x we call it as partial derivative. That means it will differentiate the only dependent term x, only the x multiple term. For that, simply we are going to write gradient of t, delta t, equal to x cap dou t by dou x, dou t by dou x plus y cap into dou t by dou y plus z cap into dou t by dou z. This is the gradient of a function t. So this is the mathematical steps. Actually, what is the physical significance? What it gives? The gradient is actually, it is a vector, tells how much something changes as moving from one point to another point. What it indicates here, if we take this t as a function of temperature, this t indicates the temperature at xyz position. If you consider the three-dimensional axis, there is a room, so in this room the temperature is varying point to point. So at this point the temperature may be different, so you take it as x1, y1, z1, or at this point the temperature is varying, this is also temperature varying. Now how much the temperature is varying, so that is we have to find out, and in which direction the temperature is varying. Actually the temperature is varying at each point, so in which direction the temperature is varying, whether at this horizontal plane the temperature may be a constant, as you move vertically upward there is a rapid change of temperature. So that is obtained by the gradient functions. Here the t, I am taking it as an example of temperatures. Now the physical significance, like any vector, the gradient is a vector, tells how much something changes as move from one point to another point. The gradient is multi-dimensional rate of change of particular functions, because that function is changes in all the dimensions, in all the directions. For that it will be called as multi-dimensional rate of change of particular function. The gradient is a vector function which operate on a scalar function to produce a vector whose scale is maximum rate of change of a function at the rate of gradient, at the point of gradient. The magnitude of gradient of a function gives the slope along maximal directions. So how can we say that this gradient of a function is a vector? Actually this temperature, if you take temperature, temperature is a scalar quantity. This del is considered as a vector quantity. So as you know, when multiply or when operate on a scalar, then it becomes vectors. So del t, gradient of t, will becomes x cap dou t by dou x, y cap dou t by dou y, z cap dou t by. Here x cap, y cap, z cap, these are the unit vectors that indicates this gradient of t is a vector. Initially there is a scalar function. When operate on a del through gradient, then it becomes a vector function. That's why it has a directional changes. Now take an example or a problem, then we will understand how we can say that there is a maximal rate of change of function is there. Yes. Find the gradient of r. R is a function. So here, what is this r? R is the magnitude of position vector, not a vector, it is a magnitude of position vector. So r equal to square root of x square plus y square plus z square. Now we have to find the gradient of this r. Gradient of r means del r. So to find this, first we know the del operator, then the r. The del operator is given by x cap dou by dou x plus y cap dou by dou z plus z cap, sorry, dou by dou y dou by dou z. To this we are going to operate del with r, the magnitude of position, then this becomes x cap dou by dou x plus y cap dou by dou y plus z cap dou by dou z. The r value is square root of x square plus y square plus z square. So operate now, it becomes x cap dou of square root of x square plus y square plus z square divided by dou x. Similarly, y cap dou square root of x square plus y square plus z square divided by dou y plus z cap dou by dou z of square root of x square plus y square plus z square. Now we have to differentiate partially. That partial differentiation indicates the only differentiate the terms multiple of this dou x. For that, the partial differentiation of this becomes 1 divided by 2 square root of x square plus y square plus z square, again this x square, so that becomes 2x. The unit vector is x cap. Similarly, differentiation of the square root of x square y square z square with respect to y, that is partial differentiation, 1 by 2 root x, so that is 1 by 2 root x square plus y square plus z square, and then this y square term only, it becomes 2y. The unit vector is y cap. Similarly, the another term, 1 divided by 2 root of x square y square z square, and then the partial differentiation of this z term is 2z. The unit vector is z cap. Now this 2 get cancelled, this 2 get cancelled, and this 2 get cancelled. From these three terms, what is the common? Square root of x square y square z square is the common, so it becomes x cap x cap plus y cap plus z cap, and the common term is square root of x square y square z square is the common term. For that I am writing it as square root of x square plus y square plus z square. What it gives? What is x cap y cap z cap? It is the position vector r bar divided by what is square root of x square y square z square? In the given problems itself, it says the magnitude of the position vector, that is r. What it gives? R cap. Okay. So like that we have to find the gradient of a functions. So this indicates there is a maximal change along the radial directions. This unit vector is along the radial direction, for that it indicates the maximal changes to this unit vector. Okay, this is about the gradient and how to find the gradient of our functions. Now take an assignment question. Find the gradient of following functions: f of x y z, that is equal to x square plus y square plus z power 4. And another question: f of x y z equal to x square y cube z power 4. And one more is f of x y z e raised to x sin x into ln y. Okay. Careful with the partial differentiations. The only that multiple of that differential term we have to differentiate. Okay. Next class we are going to study about the divergence and curl of a vector field or vector functions. Thank you.